Hello guys, in this video what we are going to do is to understand probability. Probability is the chance of something to happen. It's PC. It's the likelihood or chance of an event occurring. Basically, in math, we use a number between 0 and 1 to represent this probability. I want to show you this diagram because we have three values here, 0, 0 0.5, and 1. So what is the meaning when the probability is 0? That this is impossible, okay? When we have probability equals 1, is because it's going to happen. So we are super sure, 100% sure that the event is going to happen, okay? So be careful with this. We never use negative values, but also values greater than 1. And by the way, in the IV context, we use decimals or fractions to represent probability. For example, we can say 3 out of 8, or also we can use a decimal 0.2, okay? But we do not use percentages, okay? Only if the question asks about a percentage, you can use a percentage. But in general, always we use fractions or decimals to represent probability, and again, between 0 and 1. Okay, then we have some definitions. A trial is when we perform an experiment many times. So basically, it's the number of times that we are going to do an experiment. The outcome is the result of the experiment. Okay, for example, tossing a coin, we can get heads or tails. So we have two outcomes. If we repeat this experiment, I don't know, 5, 10 times, this will be the number of trials. Okay, this is super easy. Then this is important when we are going to calculate some probabilities. Sample space. So what is the sample space? Okay, we need to consider first the definition. That is all the possible outcomes, all the possible results from the experiment. Okay, we are going to use this letter U to represent the sample space. Sample space. U represents sample space. So, for example, this one. If we have the experiment rolling a die, one single die, a classic die has 1, 2, 3, 4, and 6 numbers. Okay, so we can say the sample space is from 1 to 6. So in math, we can write down this like the sample space U is 1, 2, 3, 4, 5, and 6. So this is the way that we represent the sample space. Okay, so we are going to use this in a moment. Then this is the probability between 0 and 1. Then we are going to talk about three kinds of probabilities. The first one I want to show you is subjective probability. This one is based on opinions, beliefs, personal judgment, or also your knowledge and experience. Okay, so for example, when you are with your friends talking about the weather, by I don't know, you can use a number between 0 and 1 to say the probability that today is going to rain is 0.3 or 0.6, whatever you want. Or if you're talking about a soccer game, you can say the probability that this team is going to win is 0.6. So this is based on your opinion. And when you are not using calculations or mathematics, only your opinions, this is subjective probability. This is the first one. The second one that I want to show you is the experimental probability. This one is a little bit tricky because first we need to perform the experiment. This is the key. We must perform the experiment in order to give a value between 0 and 1 that is going to represent the probability. For example, guys, we already know that if we use a coin, we have heads or tails. And we know beforehand that getting heads is the probability is 0.5 and getting tails is 0.5. But that is theoretical probability. When we are talking about experimental, we need to perform the experiment. Okay, so pay attention to this one, because here, let me show you. If we have this is a simulator. I want to perform, first we need to set a number of trials. So imagine that in this case, my number of trials, I want to perform 5 trials. So my event, I want to know the probability of getting tails. Probability of getting tails. So we must perform the experiment 5 times. So if we perform 1, this is the first one, heads. 2, tails. 3, tails. 4, tails. The last one, heads. Okay, so as you can see here, so we did the experiment. We have these results, heads, tails, 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 heads. So the sample, guys, like here, we need to check what is the probability of getting tails. So basically, according to this experiment, this particular experiment, we can say that we have 3 out of 5 trials. So this is the probability. So as you can see, it's something different when we use theoretical and then when we have experimental probability. So what is theoretical? Theoretical, first, is when we do not perform the experiment because we know the probabilities of each outcome beforehand. Okay, so first we have a formula. This is, we can read this like the probability of the event A. Okay, the event A. Then it's going to be n, the number of times that the event A is true, divided by the number of what? Of outcomes. Okay, the number of outcomes in the sample space. Okay, so let me show you. Specifically, if we want to use the toss in a coin example, here, because we have theoretical, we do not perform the experiment because we already know that if we have only 2 options, heads and tails, here when we have theoretical, this is super important, when we have theoretical probability, we are going to do an assumption. What is this assumption? The assumption is every single outcome has the same probability, or the outcomes are equally likely. What is the meaning of this? So that they have the same probability. So because we have 2 outcomes and the maximum probability is 1, each result has 0.5, 0.5, 0.5. Okay, so if we are going to perform, well, we need to find the probability of getting heads. Pay attention, this is my event. We already know that this is the formula. So this is like the probability of getting heads is the number of times that getting heads can be true according to the sample space. So because the sample space we have only heads and tails, is one single time that this can be true. In this case, we are going to focus on one single trial. So this is like 1. Okay, this is one single time the event getting heads can be true, divided by the number of outcomes. Okay, the number of outcomes. We have 2 outcomes. It could be heads or tails. So this is 1 divided by 2, and we get this super famous 0.5. Okay, so here we didn't perform any experiment. We use the theoretical probability. And remember, the assumption is all the outcomes, they are equally likely to happen. Considering this, we can solve this exercise. This is a classic exercise about probability, the very basics of probability. We have Michelle randomly selects a ticket from a basket containing 3 green, 4 yellow, and 5 blue tickets. Determine the probability of getting. We have the formula, and then we have some questions. So before, in order to use our formula, we need to find out the number of outcomes. So in this case, what is the event? For example, well, before the event, the number of outcomes, we have 3 plus 4 plus 5. Okay, so we need to sum this. So we have 12 tickets, maximum 12 tickets. So the number, this one, it's going to be 12. Okay, so n of u, the number of the sample space, is 12. So the event A, green ticket, we need to find this one, the probability of getting a green ticket. This is the number of times that taking or getting a green ticket can be true. In this case, 3 out of what? Out of the number of possibilities, 3 out of 12. Okay, so in this case, you can leave your result like this, or also you can say this is 1 divided by 4. It's the same. Or also, if you want, you can use decimals, 0.25. Okay, but we do not use percentages because they are not asking about any percentage here. So what about B? For B, we have a green or yellow ticket. Probability, green or yellow. So again, the sample space is the same, 12, but now we need to add the green, 3 green tickets plus 4. So this is like 7 divided by 12. What about C? The orange ticket, probability of getting orange ticket. So I think this is a tricky question because we don't have orange color. So because we don't have orange, it's 0 divided by 12. So basically this is 0, impossible because we don't have orange. What about this one here? Let me do this. So this is letter D, a green, yellow, or blue ticket. Probability of green, yellow, blue. So we have green, yellow, blue. So as you can see, this is 12 divided by 12. So this is 1. So we are super sure that we can get green or yellow or blue. Easy peasy. Then E, probability of getting a purple. This would be 0. We don't have purple tickets. And F, again, 0. A negative probability, it's impossible. Remember, probability is between 0 and 1. We never use negative values or values greater than 1. So this is 0, impossible. Okay, so in this context, 0 means impossible to happen. So that's it. This is easy peasy. So what we are going to do to complete this example is we are going to talk about the expected value. The expected value is something very interesting because we can use it to make predictions or estimations. So what is this? Basically, expected value is the expected average that if we perform an experiment, let me see, is the measure, guys, that if we perform an experiment, is the average that we are going to have, or we are going to get a result. In a moment, I'm going to do an exercise, and I think I want to explain this better. So basically, we have a formula here, this one. Let me explain this. The formula, the expected value of the event X is the number of trials times probability. N N is the number of trials. P is the probability of the event. So let me explain this better. So when we have this example of favorite coin is flipped 14 times, okay, 14, let me highlight this, predict the number. So predict the number of times you expect a head to be face up. Okay, so this is something theoretical because we are not going to perform the experiment. This is the first thing. Then if we want to use the equation, the new equation, we have expected value of the event getting heads. So n is the number of trials that we are going to perform theoretically this experiment. So this is 14 times the probability of getting heads. Remember, this is 0.5. 0.5. Okay, so this is 7. Guess what? What is the meaning of this 7? Okay, so this means if we perform 14 times flipping a coin, we are going to expect to get heads 7 times. That is the meaning of this expected value. Okay, so this is something theoretically, because if we perform an experiment, we can get something super different or the same. But this is the way that we can use expected value to make predictions. So every single time that we have predict the number of blah blah blah, or estimate the number or if we have find expected value of, we are going to do a prediction. It's something like, if we perform the experiment 20 times, how many blah blah blah, no? How many times you will get heads. Okay, so this is everything about expected value. To complete this video tutorial about probability, guys, we are going to consider the two-way tables or contingency table. This is a way to represent an experiment or event, okay, and we can use it to find probabilities. For example, this one. Two-way tables, we have two-way because we have the relationship between two variables, okay, two variables. For example, guys, this one. This variable, we can represent this by saying transportation. We can say here, this is transportation. And we can say that this is obviously gender. So the table represents a gender versus transportation. So we have two variables. But what is the meaning? For example, this one, 37. So the 37 is telling you 37 males are using the car as a transportation. Or we can use, for example, this one, 5. It's telling you that 5 females, they use bicycle. Or what about this 10? It's telling you that 10 males are using the bus. Okay, so that is every single time that we have a table like this, we need to consider two variables. So this is an example. I want to show you how we can use a table like this to find probabilities, and there are two kind of exercises. This is the very basic exercise, and the second one we are going to use the expected value, and that's it. So in this example we have a two-way tables, and then what else? We have a local coffee shop asking customers whether they prefer coffee or tea. So then we have, this is like the kind of customer, and this is like the beverage preference. Okay, so we have two variables. Use this data to estimate the probability that a randomly chosen customer prefers coffee. Okay, so if you remember the formula, let me write down the formula, is the probability of the event A is the number of times this event A can be true divided by the number of outcomes. This is important. Number of outcomes. So basically here, what we must do first is to find the number of outcomes, the results, all the possibilities. So here the results are the customers, the number of customers. We have two options. What we can do is a sum. If you remember, let me do this. A row is something horizontally, and a column is what we have to check vertically. So we have two options. We can sum the rows like this, like 60 plus 20. Obviously, this is 80. 25 plus 15. This is 40. Okay, so then we sum this 120. This 120 represents the total number of customers. So is the total number of results. Okay, or if you want, you can use the columns. You can sum this like 60 plus 25. This is 85. Then 20 plus 15, 35. Then we can sum this, and we are going to have the same result, 120. Okay, so this is step number 1. To sum, to find the total number of possibilities or outcomes. Okay, so now we have the 120. So it's going to be easier, because if we want to find the probability that a customer prefers coffee, this one prefers coffee, is not telling you that this is a regular or occasional customer. So it's talking about in general. So prefers coffee. So we must this preferred coffee. We have 60 plus 20, and we have 80. 80 out of 120. So we can say this is 80 out of 120. So you can leave the result like this, or you can use 2 divided by 3. Okay, or also you can use decimals as you want. So B is a regular customer and prefers tea. So here we need to check the intersections. So because we have regular customer, we need to check the column regular customer. This is like this, but at the same time prefers tea. So prefers tea is like this. So the intersection, this one, prefers tea and regular customer, is 25. So we can say 25 divided by 120. This is the result. Then is an occasional customer or prefers tea. Again, we need to check the intersection. Occasional customer and prefers tea. So it's this one. Occasional customer and prefers tea. So it's 20 out of 120. So this is 20 divided by 120. Then number 2, here comes a little trick. Considering the regular customers only. This one. Let me see. Customers only. Okay. What is the probability to choose one that prefers tea? Okay, this is a good one. So if we only check customers only, regular customers, sorry, we have 85. This is the sum of regular customers. So the sample space for this question is 85. What is the probability to choose one that prefers tea? So 60 divided by 85. 60 divided by 85. That's it. So this is how we can use a table, a two-way table or contingency table, to find probabilities. Let me do the last example, this one. Okay. So you can pause the video to read, because I want to show you how to use the expected value when we have a table, a two-way table. So according to this, I have my sample space here. I have 239. In this case, we have shoppers, I think. Yes, shoppers. So the sample space is 239 shoppers. I want to do 1, 2, and 3, and then we can leave like this. Exercise is only to show you how to find the expected value. So for example, one shopper is randomly the number one, and find the probability that this shopper traveled by car. One shopper, again, it's not telling you anything about the gender, so it's in general. So only travel by car, the sum is 73. So for number one, guys, number one, we can say, okay, number one is 73 out of 239, because this is the total number of people using the car and out of the sample space. Number two, let me see. Number two, we have, considering only male shoppers, find the probability that this shopper traveled on foot. Only males. So now the sample space is going to be 136, because this is the sum. Pay attention here. Male, the sum, all the males, they are 136. Then we need to check travel on foot. So 37 are traveling by foot. So this is 37 out of 136. The last one, this is the good one. Using expected value. So this is using expected value to do or to perform an estimation. So we have 1,300 shoppers visit the town in 1 week. Estimate the number of shoppers who travel by bus. Okay, if you remember the formula says this, NP. So N is the number of trials, and P the probability. So, and guess what? What would be the meaning of trials here, according to this context? Because we have, okay, according to this context, the number of trials is a shopper entering the small city. Okay, so basically a shopper getting into this small city, that would be the trial or the experiment. Okay, and the result could be first a male using the car, a male using the bus, something like that. Okay, so the number of shoppers is going to be the number of trials. That is the trick. Okay, again, here the trial is a shopper visiting the small city. So we have 1,300 shoppers visiting. So it's 1,000. So the expected value is going to be 1,300 times the probability of this event. Which event? Let me see. We have estimated the number who travel by bus. So traveling by bus. So travel by bus is 100. Okay, so the probability is 100 out of 239. Okay, so if we perform this using the calculator, we get 139. This is 543.93 shoppers. But pay attention here, what we can do, because we are talking about people, we can say 544 shoppers. So as you can see, this is an estimation. This is an, we can say, a prediction. If 1,300 shoppers visit this town, okay, we are going to expect 500. Okay, and remember, this is traveling by bus. We must expect 544 shoppers traveling by bus. Okay, that's it. So you can try number 4 and 5. So what we need to change, for example, here is the number of trials, and to check each probability, and that's it. Thank you.